In this video, we are going to continue our discussion on the Iris dataset in Tableau. So this is what we got in the previous video, that is the data on the basis of the petal width and the petal length, and as soon as we brought this species into the colors part, these are the three clusters we got. Now what is this cluster? If you take a look at this blue portion, let me just select all of that. So this is a blue portion, and we can just a second, we can just click on keep only if that's possible. Okay, that's not possible. So let's just work this way. So this blue portion is selected, right? That means all the data points which have a lower petal length and a lower petal width are in this Iris setosa species, right? So they are given a cluster, means they are collected together. So if any new data or if any new point occurs like over here or over here, that is near to this cluster, then our system or our machine learning algorithm would be able to classify it as Iris setosa. So this is what the purpose of a machine learning algorithm is. To work on the previous data set, firstly it works on the previous data set, that is this data set, suppose, and now it has got a parameter on how it is going to work. Now if any new data comes, it would be able to classify it very easily as Iris setosa. That is, if any data set which is given a lower petal length and a lower petal width, it would be Iris setosa. Okay. Next we have is Iris versicolor. So if we just go on keep only Iris versicolor, okay, so keep only won't work, we can just select it like this. So what will happen is, in the case of Iris versicolor, that's orange, the petal length is between 3 cm to 5.5 cm. Similarly, the petal width is between 1 cm to 2 cm. All the data between this range is in Iris versicolor, with a few exceptions, like this is just below 3 or it is an exact 3, right? And this is 1.8, this is exact 1, like this. So all this data we are having, that means any of the data which is in these range would be classified as Iris versicolor. The third is Iris virginica, and this is the data we are getting for Iris virginica, although some of the data for Iris versicolor and Iris virginica is colliding with one another, like these 2 points. So it might be a little bit difficult to classify them correctly, but we can get a pretty good accuracy through these clusters, right? That is the collection of the similar kind of data. Why are they called clusters, or how are they found, or how are they formed? That is through the center point. Each of these clusters have a center point, and the data that is taken, its distance from the center point is taken. If that distance is within the available range, so that data point is classified as that particular cluster. Otherwise, it is classified as a part of some other cluster. Suppose if I have a data point over here, right? So it is closer to this orange color cluster, so it would be classified as Iris versicolor instead of this virginica or setosa. However, if it is over here, so it is closer to this particular cluster, that's why it would be classified as setosa. So that is how the classification occurs. This is just one machine learning algorithm, which is the clustering algorithm. Okay, so we are using this clustering algorithm, and this is the k-means clustering algorithm. That means we have the n number of clusters, or the k number of clusters. Here the number of clusters is 3, that is setosa, versicolor and virginica, right? This is on the basis of the petal width and the petal length. Similarly, we are going to do the exact analysis on the basis of the sepal length and sepal width. Why are we doing these two things? I will explain you just a few seconds later. So here we had the length in the columns. Let's do the same thing. Sepal length in the columns and sepal width in the rows. Make sure the aggregate measures are unchecked. This is what we are getting if we go to species and bring in the color parameter over here. So this is the clusters. Let me just get the entire view. This is the clusters we are getting on the basis of the sepal width and the sepal length. That means the this blue part is setosa, orange part is versicolor, and the red part is virginica. Now, if you take a look at these two data sets or these two graphs, then what do you think is best for identifying the type of a new data. Of course, it's the petal length and the petal width, because in the case of sepal length and sepal width, the data is all clubbed together, right? So we cannot use this as a parameter. It is essential to compare both of them because we wanted the best results for us, best results for our algorithm, best results for our model. And when we compared them, we found that petal width and the petal length is a better parameter for the cluster, for finding out the clusters, right? Now the sepal length has been rejected, so we can move this sheet over here and work with this petal. This is the data that was given to us. Now what happens is, we are going to create a machine learning algorithm and allow it to find this out on itself. Okay, so what are we going to do? We are going to create the ML algo. This is the ML algo. It would be created on the basis of the petal length and the petal width. Just make sure that the length is in the columns in the actual data as well. Yes. Same, go to analysis and check the aggregate measures. So this is the data and we have to classify it. So how do we classify it? Using machine learning algorithm, you need to go to this analytics tab. Here we have this cluster in the models. You see, this is the models. That means it is a machine learning models. And here we have a clusters. So if we just open it up, these are the variables that it has taken, and if you want a specific number of clusters, you can specify that, otherwise it automatically takes it, and automatically it has identified 3 clusters. Let me just change it to entire view. This is what our algorithm has predicted. Our algorithm has predicted that this is cluster number 1, this is cluster number 2, and this is cluster number 3. This looks a very good prediction. However, there is some issue in this. Like if you just go to this actual data and you see that these two, this is a red color Virginica, this is also a red colored Virginica. However, in the case of machine learning algorithm, this is also taken in cluster 2 and this is also taken in cluster 2, which means of course the data is not 100% accurate. Despite that, it is a pretty good result, because 100% accuracy is not achievable, especially in data science, because that would mean that we have overfitted our data, and overfitting is always an issue. It may work for some data, but for the unseen or the new data, it may pose the problems. That is why a higher accuracy is good, above 60 to 70%. Anything above that is considered to be good. So we would be finding about the accuracy of this model as well. Okay, but before that, what we are going to do is, right now if you see, we have created 3 clusters, or the algorithm has created 3 clusters, 1, 2 and 3, but we want them to be specified as these species, Setosa, versicolor and Virginica. So what we can do is, we need to go to this sheet, drag these clusters into the tables. Just a second. Create a copy of it and drag it into the table, so a new column would be created, and that would be the clusters. Let's just name it as clusters. K-means. Okay, that's just the name of the algorithm. Now what I'm gonna do is, instead of 1, 2 and 3, I'm just gonna change its names. So how are we gonna do that? Let me come to this petal data. Here I'm just going to edit this group. The cluster 1 is going to be the Iris Setosa. So it's going to be Iris Setosa. Next is going to be the Iris versicolor. So Iris versicolor. Now you need to make one thing really sure over here, is that there is no spelling mistakes. If there is a spelling mistake, then the accuracy of the model would be affected. How? We will just take a few seconds to talk about that, and that's done. Click on apply, click on OK. Now if you go to ML algorithm, we have clusters k-means. We can drop it into the colors part, and now we are getting these cluster names as the species names. We don't have those cluster 1, cluster 2 and cluster 3, right? Now how are we gonna talk about the accuracy of this model, or how are we gonna find out the accuracy of the model? We will see it in the next video. That's all for this one. Thanks for watching.